Okay, here's where the answers to your warm up, so you are actually able to check them if you would like. We're going to talk today about solving absolute value equations. So when we have absolute value inequalities, we have two cases where the absolute value of a number is greater than or equal to something, as in case 1. And in this case, we know that x is greater than or equal to 7. And we know also that x is less than or equal to -7. Okay, so that's our one case. So if x is greater than or equal to 7, I have an arrow going in that direction. Okay. If I have x less than -7, I'm going to have an arrow going in that direction. So this is an or situation. Our number has to be set more than 7 units away from 0. So that's why it's going in opposite directions, and why x is going to be less than or equal to -7, or x is greater than or equal to 7. So in interval notation, I'm going from -infinity to -7, union with in 7 to infinity. And those are included, so we're actually going to be using a bracket instead of a parenthesis for those numbers. Okay. Now, this second equation means that whatever x is has to be less than 4 units from the origin. So here's my origin, less than 4 units. Okay, so there's 4, here's -4. We know that from equations, right? We know that the absolute value of x equal to 4 means x is equal to 4 and x is equal to -4. But now we want that distance to be less than or equal to 4. So from here to here is less than 4 units from 0. And from here to here is also less than 4 units from 0. Okay, so this, going back to our compound inequalities, is an and. We said this was an or. Okay, so we know that x is less than or equal to 4, and x is greater than or equal to -4. And then our interval notation, brackets, because it's included, -4 to 4. Just like solving absolute value equations, we're going to get the absolute value symbols in that expression that's in it all by itself as the very first step. So we're going to add or subtract if necessary, multiply or divide if necessary to get the absolute value symbols alone. We're then going to write two inequalities. But when we write them, we're going to get rid of the absolute value symbols, write our original. But when we write the negative, we're going to flip the order sign. Okay? So whenever we write that second inequality, the absolute value symbol and the negative now on the other side, we flip the order symbols. We're then going to finish solving the inequalities just like a regular inequality. And lastly, we are going to graph our solution. Let's take a look at a couple examples. Okay. If I look at this first example, I don't have the absolute value symbols by itself. So here they are. They're not by itself. So I need to get rid of that 3 by subtracting 3. When I do that, I'm going to get the absolute value of 8a plus 10 less than 22. Now I have the absolute value symbols by itself, so I'm going to write my two inequalities, my original without the absolute value symbols, and the other one with that right side negated. And when I negate it, I flip my order symbol. So instead of less than, it becomes greater than. And then I just solve this like I would normally solve an inequality. So that I subtract 10 from both sides, I'm going to get 8a equal to 12. If I divide by 8, I'm going to get 12 eighths. Now we're going to start leaving things in fractions. Okay. So what we need to look at is what divides both 12 and 8, and it's 4. So we're going to reduce that. This should be less than. I was doing that all day today in class. Less than 12 divided by 4 is 3, and 8 divided by 4 is 2. So A is less than 3 halves. If I subtract now for the second, solving the second inequality, okay, I'm going to subtract 10, and I get 8a is greater than negative 32. And if I divide both sides by 8, a is going to be greater than negative 4. Okay. So this is less than when I get this by itself. So that means that my numbers are not going to be further away than the 3 halves and the negative 4. It's going to be in between. So whenever you get the absolute value symbols alone, you see a less than or a less than or equal to. This is an and, okay? And my graphs are going to run together. So greater than negative 4 and less than 3 halves, which is about 1.5, so in between here. And then we just connect those dots. Okay. In interval notation, we're going to use parentheses because that open circle means that 3 halves and negative 4 aren't in the solution set. So I'm going to go negative 4 to 3 halves, and I'm using parentheses because they are not in the solution set. I did not put, for whatever silly reason, absolute value symbol in equals here, so we're going to put them around the q minus 1. Okay. So now I have to get rid of the 4. I got to get that absolute value symbol by itself, so I'm going to multiply both sides by 4. Okay. When I do that, I'm going to get q minus 1 is greater than or equal to 8. I'm going to write my absolute value of that. I'm going to write my two equations. Okay. The original q minus 1 is greater than or equal to 8, and then q minus 1 is less than, we're flipping the order symbol and negating the other side, negative 8. So all I have to do to solve this is add 1 to both sides in each inequality. So q is going to be greater than or equal to 9, and negative 8 plus 1, q is less than or equal to negative 7. I've added 1 there. Okay. So q is going to be greater than 9, but it's going to be less than negative 7. And the distance is going to be greater. The distance from the center is going to be more than that 8. So when it is greater than or equal to or just greater than, this is the or, and they go in different directions. So q is greater than or equal to 9, and q is less than or equal to negative 7. And we're closing in the circles because it's included. Okay. Now, if you think about this inequality, it makes sense that it's an or because q is going to be greater than or equal to 9. So it's going to go off to the numbers are bigger and bigger. And q is less than, it's going to go negative to negative infinity. So our interval notation is negative infinity to -7. Remember, we go the beginning of our graph from over here to the end of our graph, union with 9 to infinity. It's a bad infinity sign, sorry. All right, next. Okay, again, my absolute value symbols are not alone because that means 10 times the absolute value of 2r minus 1. That means I'm going to divide both sides by 10. And I'm going to get the absolute value of 2r minus 1 is less than -6. Okay. I'm hoping that after dealing with absolute value equations that this is bothering some of you. Okay. It would bother me. Okay. And I want you to think about what absolute value is. You can pause it and think, take a wild guess, talk to your neighbor. Okay. All right, do you have an idea? So here's the deal. Remember, absolute value is always, always positive. So it doesn't matter what my value for R is going to be. These absolute value symbols are going to force that whole side to become positive. Okay. And we're saying that a positive number is less than a -6. Well, folks, a positive number is never, ever going to be less than -6, ever. So there is actually no solution to this. Okay. So sometimes you will see that written like a 0 with a line through it. That means an empty set, or a bracket, open brackets like that, braces, and that means empty set as well. If you're not sure of the symbols, it's just easier to write no solution. But remember, a positive number will never be less than a negative number, so there is no solution to this. Keeping that in mind, take a look at this next equation. All right, so keeping all of that in mind, I want you to solve this. Take your times, solve it, and see what you get. I want you to pause this and wait. Do you have an answer? Did you think about it? Is it no solution? What's the deal? You could also talk about it with a friend. But the first thing I need to do is I want to get -9 by itself. So I'm going to subtract 9 from both sides. So I'm going to get 4 times the absolute value of 9 minus 3n is greater than -84. Always, always, you should add or subtract first if you're trying to get that by itself. Okay, now I have 4 times that absolute value, so I'm going to divide both sides by 4. And I get the absolute value of 9 minus 3n is greater than -21. Hopefully some alarm bells went off on your head and said, there's a negative there. If you did that, that's a win. Okay. However, it's not no solution. Remember that absolute value is always, always positive, right? So a positive number will always be greater than a negative number. Always. Okay? So that means that this is all real numbers, or negative infinity to positive infinity. And when we graph it, it is just a line with arrows going in all directions. Some really good things to remember, okay, is that we have to get the absolute value symbols alone. Once we've done that, we can write our two inequalities, and then we would solve like we normally would. Then we're going to graph and it's going to be an and or an or. So remember that if once you get those absolute value symbols alone, okay, you get a greater than or a greater than or equal to, okay, that is going to be an or. And my arrows are going to go in different directions. Okay. If I get less than or equal to or less than, that is an and we're going to connect. Lastly, if I get whatever is in my absolute value symbols greater than a negative number, okay, that is going to be all real numbers because a positive number will always be larger than a negative number. Okay. If I get all the absolute value symbols alone and I get less than a negative number, it's never ever going to be true. So there is no solution. Okay. I hope you're behaving for your sub